about the midterm. Okay, so the first is the lightning round part. You need to look at quizzes. So those kind of questions are ones that will questions like that will show up on the test. Keep in mind how many questions of each type you're supposed to do. It'll say so on the test, depending on our one undergrad. So if you're not Megan, then this is how many questions you do. All right. Now, as for the regular problems, okay, so things that come up in these problems, like for example, carrying out Gauss elimination, possibly with one of the two pivoting schemes that I covered, partial or complete, which you also had to do on the second homework. If asked, be able to produce the LU decomposition of a given matrix. And there's a basic will be processed Gauss elimination to get LU, then forward substitution of L, back substitution of U. Okay, keep in mind as far as forming the LU decomposition, whenever you're eliminating an entry, your multiplier is always whatever you're trying to eliminate, so Aij divided by Hj. It's a good idea to write down explicitly what your multipliers are, just so I can follow your process. And which is helpful for giving partial credit in case the final result is incorrect. Whatever the multiplier is at Aij over Hj, that goes into the Ij entry of L. That's how you make L at the end. You might have pivoting. If you perform pivoting, then you should not only are you swapping the matrix you're still working on and reducing to the upper triangular form U, but if you're like writing down the multipliers in your L as you go, if you swap rows, you gotta swap rows there too. So just swap everything, and you'll have the correct result. Here's an example of what I mean by that, as far as keep track of multipliers even if pivoting is involved. And like I said, beware of partial and complete pivoting. With complete pivoting, you're swapping rows and columns. And you might where you're looking for an entry to swap with. So partial pivoting, you're working on one column at a time. You're really looking at a portion of column J from the diagonal entry on down to the bottom. There's complete pivoting. You're working on column J. You'll take that submatrix, rows and columns, J through N. And find the largest entry in that portion, and then swap rows or columns to put it in the JJ position. Also, again, for partial credit purposes, if you're doing Gauss elimination, somehow indicate what row operations you're doing, in case there's a little mistake that throws everything off. When I took my first numerical analysis class, which was in 1988, one of the problems was, here's a X equals B problem for Gauss elimination, partial pivoting, to get the LU decomposition, do forward back substitution. And so I went through it, and I felt like everything was going okay. But I felt like I got the right answer. So then I was talking to a classmate afterwards, and he mentioned like, oh, for the answer you just get 101 for X. It's like, oh, of course you do. Yeah, I did not get that. So I was freaking out all weekend long, wondering how many points I was going to lose for what must have been a silly mistake, because I felt like I knew the process. And I got lucky that, it was this one little thing, and they were merciful partial credit, so I only lost like 2 points on a 15-point question. But yeah, it's like, it's kind of amusing that the things that I teach about today that everyone here assumes that I'm an expert in, and yet screwed up so badly as a student. So, which also should give all of you hope. It's all about just the immersion. Just, okay. Now let's see what else we got here. Okay. All right. So, abandoned matrices. How's LU behave? That reduces how many entries per column you need to eliminate, and also how many entries are affected when you perform the row operation. Cholesky factorization. So if you, so this matrix equation, you write out what G transpose is, where G is lower triangular, and equate these to A, then you can figure out what all the entries of G should be by going from left to right through the columns. Like I did an example in class. Condition number. There is a problem that involves a condition number, norm of A inverse. Now, computing the inverse is not easy unless it's a 2 by 2 matrix. So this formula will come into play. So certainly for a 2 by 2 matrix in whatever norm, well, aside from the 2 norm, it's not too much computation involved to compute the condition number. Can you find the norms that are practical to compute? Matrix norms. The one norm of the matrix, you take the largest column sum. The fitting norm of a matrix is the largest row sum. Frobenius norm is square root of sum squares of all the entries of the matrix. So let's run down the things you should be able to do on a test, that at least in this setting, since we're still in COVID mode, not putting anyone under the gun. Are there any questions, like for instance, about a practice test?
Can I ask one thing just about the formatting again that you have at the top? You have what we had to answer and all that. I remember the final from 560. Is it like 12? Are there 12 questions offered on the lightning round, or is it more offered? And how we go in about that?
You know what? I'm going to, since y'all are not able to see it, I'm going to open up a real test. Just so giving correct information, because I honestly don't remember. Okay.
How much possibility do we have for extra credit?
Potentially, right?
Okay, so unfortunately for graduate students, there's no leeway.
Okay,
There are 12 questions, you need to answer all of them.
That's fair enough.
Okay.
Just had to
So,
ask.
as far as point values, I think, so looking at the rest of it, so I don't have a clear statement here. Okay, what if I have something from my previous notes? Okay, so for instance, the 5 regular problems, make sure it didn't suddenly put the real test up on the screen. All Alright, so you have 12 lightning round questions, and then there's 5 regular problems.
I thought 12 regular problems, okay.
Oh, that would have been terrible.
I'm just sitting here thinking.
Okay, so numbers might not work out all that nicely, but
Looks like we're gonna have to
There
have
is-
credit problems.
we want to make it work roughly so that it's like about half for each portion. Okay. All right, I'll put it top of the notes here. So for regular problems. All right. Dang it. As far as point values, so it adds up to 100. Okay, so in this case, so they may have fewer questions, but there's more pressure for each one. Okay. All right. Let's say the total question for the end of the test handout. So lazy. All right, and of course partial credit. For all kinds of questions. Okay. Yeah, because last semester in for 460, 560 for the final, yeah, there was an opportunity for bonus, and some people racked up a ton of bonus. In some cases, that really saved some people, and in other cases, it's like, well, now you have even more of an A. So, I guess the way this is set up, only one person in the class can get bonus. Knock yourself out. Okay. All right. Well, we have tons and tons of time. Questions about it? Anything like if you've taken the time to look through the practice, or any issues there? Okay, yeah.
I have one question, it's kind of stupid, but I was just wondering.
Okay.
When we are doing row operations, do we always have to do it in terms of subtraction? Because doing R3 minus negative half of R2
Yeah.
is same as doing R3 plus half of R2.
Oh, sorry, read that by me again?
I will just write it down.
Okay.
R3 minus negative half of R2. So basically just these two things.
Oh,
I'm just wondering if it's only always in terms of subtraction.
well, okay. I mean, when you are carrying it out, I don't care how. but the point is, based on how the algorithm goes, the multiplier for that operation is minus 1/2, and therefore that's what goes into L. So it's important that no matter how you perform the operation, that you have the correct items stored at the end. I guess another way of putting it is, I don't care how you do the arithmetic, I just care what you do the arithmetic with.
I'm actually confused about that in number 1. So in L, the first one comes out to 1/2, but the multiplier was negative 1/2. I'm not sure if I did it wrong.
Wait,
And the multiplier was half.
it multiplies to half.
Okay, I got it.
Yeah, and the convention is that whatever the multiplier is, you're subtracting the multiplier times that row.
Okay, that's what my question was. Multipliers are always subtraction.
And the thing is, if you think of that kind of row operation as like multiplying by elementary row matrix, which would have a minus 1/2, but it's still 1/2 is what goes into L.
Okay, so I think that's what I was kind of just
Yeah.
hearing. My L was going wrong. I think that's because of that. I wrote it as a addition. Speaking of L, can we talk through question 3? I am having difficulty finding the P.
Okay.
Actually, I'm having difficulty finding P also in number 1, but I kind of just went through it through that.
Okay. So, oh, you say you're having trouble finding the P?
Actually, recognizing the P.
Oh, okay. So, wait, I want to make sure we're on the same page, because P is in a permutation matrix?
Yeah.
Okay. The easiest way to make sure you have the correct P is, if you start, like for instance, writing it off to the side like an identity matrix, and then whenever you have to perform a row swap, like, oh, I got to swap rows 2 and 3, carry that out on that matrix, that's the identity, and just keep track of that, and that will be the P you got in the end.
That should help.
Okay.
I actually haven't gone through 4 and 5 yet, but once I do study them, I will get back to you.
Okay.
I'm halfway through 4 reading.
Yep.
Yeah, 4 was the only one that I struggled with, but it turns out I only struggled with it because I suck at arithmetic.
Oh, okay.
Yeah, I gave the wrong answer because I messed up subtraction in more than one of the equations for G.
Well, I guess in this testing environment, you have the opportunity to use certain things to help you that I would not know any different. Nor would I care. Because what you're talking about is definitely not what I'm interested in testing you on. The whole point of this class is, oh, what happens when the computer does all the work?
I have another question. Are the levels of problems on tests similar to this or a bit higher?
I try to keep it about the same. Yeah, because I've seen it happen by some instructors where they'll put something out as a sample, and then there's a huge gulf in what shows up on the real thing. And I do this to try to avoid that. And I remember one time I was teaching calculus 2, and I was giving a test, and that test is over and everybody's leaving. I can hear students say that, oh, this is nothing like what I expected. It's like, and I actually called him on it. Like, how can you say that? I put out a practice test and I see kind of problems. And, yeah.
I guess they were prepared.
What?
They were prepared.
Yeah.
I did get a couple students for Cal 2 and Cal 3 to tutor.
Yeah.
And they said their practice test looks nothing like what they've done in class and they are freaking out.
Well, I remember something at the, well, I guess now former colleague, Dr. Perry, since he's just left us, was a discussion about online homework for calculus. He talked about how he was using WebAssign. And the students would do all right on the homework. And then he would intentionally put problems of the same kind on the test. And the students would act as if they'd never seen these kind of problems before in their lives. And I know in Cal 4, I used to use MyLabs Plus. And what they would have is, for a given problem, there was a button you could say, view an example. So it would basically show up exactly the kind of problem, certain details change, so then you can just see, oh, here's what they're doing with the numbers, and get the answer that way. And some of my calculus students have admitted that that's how they do with problems on my homework, that they see how the numbers are manipulated, and so they really can get to the right answer without understanding any calculus. So it's unfortunate.
Calculus is so notation heavy too. Like, I'll realize like sometimes my students know what they're doing in a sense, but like they don't know how to notate it at all.
Yeah.
Like I can tell like that they're as they were, I don't know. Which I guess I probably have the same issue in some of my own classes, but
The problem is, on one hand, it's acknowledged by myself and my colleagues that there is a high level of mathematical illiteracy, just not knowing how to express ideas, and therefore, and we always think, okay, we really should crack down on that more, like the lower levels. And the problem is, it becomes exhausting. Like every little thing, because you feel like you're trying to empty the ocean with a spoon. In terms of some even correct conceptual knowledge expressed improperly, and you want to encourage what you see that's right. But yeah, it's and by the time one gets to this level, some of those bad habits are baked in, unfortunately. Why should be a class just about that?
The worker is very correct actually here. Often it happens that I am asking somebody something and I'm like, okay, tell me the product rule. And they're like, I don't know. And then I just write it like DDXUV, what would you do here? Then they tell me I do this. I'm like, yeah, that's product rule.
yeah.
What's a product rule?
Yeah, because like there's so many different ways to write a derivative.
There are so many ways.
Especially when this polar coordinates, it's like, what do I do?
It's the only way to write an integral.
No, the other day was really funny. Somebody came in, was like, I just don't know what the definition means. Like, what does it mean? Like, I had to explain that person what it means for a thing to approach zero.
Oh.
And it was hilarious.
So it's not, so you're not even asking what a limit means, but rather, what does it mean for like x to approach zero?
I actually used an example that I had used in past, but it was really hilarious. But it always works with them. It was just funny because I told them, like, imagine somebody brings a cookie to your class and you go and there's only one. What do you do? They're like, well, I'm polite, so I take half of it. I'm like, well, right. And then I go and then I take the half of it. And then you keep doing half. There will come a point that it's going to zero, but it will mathematically never go to zero. So that's all it means to approach zero. It's like, oh, I get it now.
Yeah.
You have good analogy.
Yeah, it's like a joke about how infinitely many mathematicians walk into a bar, and the first one orders beer, second one orders half a beer, quarter beer, and so forth. So then the bartender puts up 2 beers on the counter, and says you gotta know your limits.
That's all you're doing.
Sorry.
Oh, God, no. That's terrible. I love it. Such a nerdy joke.
Oh, I'm sorry. This is my favorite test review so far.
My mask is on upside down. I had no idea. My first year here, honestly, the students drove me nuts. I could not relate to them.
I like how he didn't adjust that. Be like, oh, now they're fine.
Things got better pretty much actually by the second year. And I think if I would matter, just like I just got unlucky with certain individuals as opposed to USM students as a whole. But there were some characters, and I knew that I was in for a rough time when I was talking to one student who was telling me that they didn't turn in one of the assignments. And I said, oh, you didn't finish it? And he said, oh, I finished it. I just didn't turn it in. Yeah, like something was going to snap in my head at that point. And one thing I did to try to, because I could tell that, I guess, whatever I was doing in class, I was using like Cal 3, and also 460, 560. Well, that one was going fine, but Cal 3 was just rough, because also we're seeing series, which is a hard thing to deal with anyway, and I'm coming from working with Stanford students to USM students, so that's an enormous bit of an adjustment, but you're always going to underestimate how much of an adjustment it is. So to try to, I guess, win the students over, or at least make them hate me less, I actually would start holding evening review sessions, where I would just come here and I also was doing practice tests, and I would just go through every little detail of them, and I had snacks. That was a key. And I discovered just how much students like Nutter Butters. Actually, yeah, I did it for like my first several years here, but it's something that really helps because it shows like, okay, like I'm really hoping that you guys get this stuff, and I'm willing to literally put in extra time to make sure that we do.
So they would show up, like.
Yeah, they did.
Good
They would show up to that more into class.
Oh,
Oh, that's.
Yeah, I sometimes have perfect attendance at a review session. It would never happen during class.
I had a professor do that at MC, but he would only do it for graduate level classes.
Oh, okay.
And we went to his house,
Oh,
and his wife would cook all sorts of just random stuff. You can bring stuff if you wanted to, but no one ever would, because his wife was going to make something way better than you could make yourself. We would just go there, and he would do some reviews on like geometry and polynomials were the two I went to, and we would just sit there, and his wife would sit in a recliner reading some book and laughing at all the hard questions because she hated math. It was enjoyable, but almost everyone showed up every single time.
yeah.
That's fun.
It's weird because I only did review sessions for undergrad classes. But yeah, my advisor had people over to, at Stanford had people over to his house all the time. And we thought, oh, that'd be cool to, once I'm a professor, to do something like that. And we actually chose a house that was kind of close to campus, but that's just not the culture here. So,
Yeah. We did it at NC. I've been to all of my professors at NC's house, but I didn't go until grad school because you have 30 students in a class, and that doesn't go in a house very well. But most of the grad classes had like 4 to 6 students. So it was great. You could go and hang out at their house. And Clinton's a small city, so everyone lived close.
Yeah. So,
I'm really sad I didn't do my undergrad here. There are so many courses I would like to retake, starting Cal 1 to Cal 4, and I don't know, so many.
Well, because you majored in something else, right?
Yeah, I did. I am actually an engineer by degree.
Yeah.
But yeah, it would have been really enjoyable.
Yep. Well, let's check and see if there are any questions that pop up in the meantime.
I have a question.
Yeah.
Number one, and it's more just for clarification between the way you work number one and your first bullet point in your review.
Oh, okay.
You mentioned do not use 326 methods.
Oh, what I mean by that is don't work with the augmented matrix.
Okay. So you do want, in number one, you do want an A, a P, an L, and a U. And
Yeah.
then forward and back substitution.
Yeah, because the other thing about what happens in 326, or a typical first linear algebra course, is trying to get like reduced echelon form, where you reduce A all the way to identity. And there's also don't forget there are three kinds of row operations. There's row interchanges, there's subtracting multiple rows from a row, and then scaling a row, which, while that is used in a typical linear algebra course from time to time, there's no use for it here.
Mm-hmm.
Yeah, so that's really what I mean by the distinction between the two.
Okay. Thank you.
Are you gonna send out the LaTeX code?
Oh, yeah, I remember I wanted to actually do that for both my classes, because the other class, 417, 517 also has a test this week. So yeah, I'll post, after making sure there are no answers in it, the tech file. And I will certainly have it posted by 5 p.m. It might be earlier, depending, but no later than that.
That's Wednesday.
Yeah. Yeah, so you'll have at least 55 hours to get it done. Not sure what that was, but okay. Yeah, so for any problem where some form of gas elimination is required, I go compare your final results, and if that is off, then I will go back through and find out your first mistake. Your partial credit accordingly.
Sorry, random note. Were we having class Wednesday?
Class will not meet on Wednesday.
Okay, thanks.
Or next Monday, for that matter. So,
Oh,
yeah, I won't see you for a while. for 9 days.
Same for my class because I put the wrong date for Mardi Gras. I have to take it back, so
Yeah.
whatever.
So they get
We're
double
coming
Mardi
back
Gras.
on
Yeah.
We'll come back on Tuesday.
Actually, there's no classes meeting Monday or Tuesday next week.
Oh, so we won't be making that.
Like our individual meeting? I can leave it up to you, because I'm gonna be here
Okay.
anyway, for that stupid community
I'm around.
meeting.
28. No, that's first.
Yeah, one year, they, gave only the Tuesday off for Mardi Gras. So they actually expected people to be in class on Monday, not on Tuesday, and back on Wednesday. That did not stick.
Yeah.
Well, it's just like this for most of you who teach every semester, grades are due the Monday after finals at 11 a.m. Except for one semester, several years ago, they made it 8 a.m.
Oh,
Don't know why. No explanation. They'll talk about quietly change it back after probably having 1,000 late grades. Well, when I first got here, I heard from some of my new colleagues that they had made a change in the academic calendar to move the start of fall semester up by a week. So faculty who were away all summer, because we're not teaching, would come back thinking they had 2 weeks to prepare for classes, only to find that they had 1. And that the change had something to do with the football schedule. So,
For our wonderful football.
yeah, so
Sorry.
that's how I knew where our priorities lay.
One and however many. I went to one football game this year and there was not a crowd.
yeah, I went to 2 games. That's because it was FOMO. Mainly, and because I had just arrived here, so everybody had twice.
Yeah, I went to a few during my first year, and after that, I was like, no.
Exactly, I was like, oh,
I loved it when I was a kid. Like, it was the closest town I could go to have a college football game. I was like, oh, these people are great. And then I got older and went, man, I was a dumb little kid. This football team sucks.
you were just a kid.
Well, besides, as soon as we have a good season, the coach leaves. So, and that's what happened when I first got here. Like after a few years, it was Fedora who won the conference championship, and he left. And then the next season, won no games. That coach slowly left, and then the next coach who won 1 game, then 3 games, then 9 games. And he left because he knew he couldn't continue the pattern. So, and then back in the dumps again. So.
Yeah, I grew up expecting the football teams that I liked to do terrible because I was a fan of USM and the Saints. And both of those two were known for losing more than winning back then. So.
You know, for AWM, we should have like a math marathon kind of thing, like 24 hours straight doing something.
The only thing I'm doing for 24 hours is possibly eating and sleeping.
Yeah.
Outside
we
of
could
that,
do
I
a
ain't
math
participating.
class.
24 hours, nothing.
We'll give you food and nap, like a sleeping bag. I wish I could do something like that.
24 hours of what?
Just kind of doing random math shit.
I see that on YouTube every once in a while. And,
I feel like it's, does that work?
yeah, I feel like my life's pretty close to that now. I don't want to get any
That's not.
closer.
I'm actually trying to feel it properly.
Just help each other with homework.
Last chance for questions of any kind. Oh, this has been fun. We should do it again sometime. And I'll stop recording here.
Next time you have to bring snacks though.
Okay.